Hello everyone, myself Umesh Karabjagan from Dr. Krishna College of Engineering, Baramati. Today we are going to discuss about the cofferdams and relation of the cotton soil topic. Generally, everyone knows that the meaning of cofferdam and its applications and the different instrument required to nail cofferdam. First up, we are going to discuss about what is meant by sheet pile. The sheet pile walls are made up of continuously locked pipe segments inside to resist the horizontal pressure, and they can tolerate relatively large deformations. A sheet pile wall consists of a series of sheet piles driven side by side into the ground, thus forming a continuous wall for the purpose of retaining an earth bank. The difference between sheet piles and retaining wall. The sheet piles are mainly used in waterfront structure, are light and do not need dewatering, whereas in gravity retaining wall are massive and need dewatering regularly. The main difference between sheet pile and retaining wall is sheet piles are flexible, whereas retaining walls are rigid. Sheet piles are more suitable where upper layers of subsoil are weak and have low bearing capacity to support gravity retaining wall. Cantilever sheet piles become uneconomical when depth of water and depth of penetration is high. Sheet piles are commonly used for waterfront structure, then temporary structure and lightweight construction. These are the various types of sheet piles: cantilever sheet piling, then anchored sheet piling, then braced sheeting. Certain configuration of sheet pilings are termed as bulkheads or cofferdams. Sheet piles used for retaining walls are classified as anchor sheet pile or cantilever sheet pile. They are made up of various materials like steel, concrete, wood, or aluminum. In geotechnical area, cantilever embedded retaining structures are used for protection of permanent and temporary excavation. Then highway constructions, landslide protection, retaining structure in form of pile walls and diaphragm. We are going to discuss about the steel sheet piles. The steel sheet pile is versatile due to its strength. It is easy to handle and it is easy to construct. Steel sheet piles are available in various cross sections. The corrosion of this sheet pile wall can be prevented by gypsum coating. A steel sheet pile having thickness is about 10 to 13 mm and it allows a stress up to 170 to 200 kPa. It is also used in brace sheet piling, double wall sheet piling or cellular cofferdam. The advantages of steel sheet piles. First one, it resists high driving stresses. Then it is lightweight. It can be used as many times. It gives long service life. It is easier to increase the pile length. Lesser deformation of joints when bridge full with soil and stones during driving. The next point we are going to discuss about the precast concrete sheet piles. The precast concrete sheet piles are heavy due to the concrete and it produces large disturbance during driving it into the ground. They provide good aesthetics and primarily used as bulkheads. They are generally 30 to 600 mm deep and 900 to 1,200 mm wide. Precast concrete sheet piles can be advantage can be used in marine environment, stream beds with high abrasion, and also where the significant axial loads are to be supported. As per the determination of thrust paper pressure activity on cantilever sheet pipe, which may be without anchorage and with anchorage. The sheet pile may be in soil, like sandy soil, both above and below the trade line, then sandy soil above line and cohesive soil below trade line, then cohesive soil both above and below the trade line. The next topic we are going to discuss about the cofferdam. Everyone knows the use of sheet piles. Like the cofferdam is a temporary structure designed to keep water and or soil out of the excavation in which a bridge pier or other structure is built. A bulkhead or cofferdam is a sheet pile retaining wall of waterfront backed up by ground. They are widely used for dock and harbor structures. A bulkhead, cofferdam, or cofferdam provides a vertical wall so that ships may tie up along sides. A bulkhead may also serve as a pier structure which may be shoot out into the water. When construction must take place below the water level, a cofferdam is built to give workers a dry work environment. Sheet piling is driven around the work site, then sealed concrete is placed into the bottom to prevent water from seeping in from underneath the sheet piling and the water is out. The cofferdam mainly comes from the coffer, that means box, in other words, a dam in the shape of box. Today we are going to discuss about some types of cofferdam. Basically, there are several types of cofferdam. First one, brace cofferdam. In brace cofferdam, it is formed from a single wall of sheet piling which is driven into the ground to form a box around the excavation line. The box is then braced on the inside and the interior is the water. Brace pipe is primarily used for bridge piers in shallow water up to the depth of 30 to 35-meter depth. The next type is earth type. Earth type is used for low-level waters with low velocity and easily scored by water rising over the top. The next one, timber creep. A timber creep uses rock ballast and soil to decrease seepage and sink into the place, and it is also known as gravity dam. Next one, double wall sheet pile. They are double wall cofferdam comprising two parallel rows of sheet piles driven into the ground and connected together by a system of tie rods. at one or more levels. The space between the walls is generally filled with a granular material such as sand, gravel, or broken rock. The next type of cofferdam is a cellular cofferdam. In cellular cofferdam, such types of dams use only in those circumstances where the excavation size precludes the use of cross-section cross-excavation bracing. Last one, the cellular type cofferdam. In cellular type cofferdam, this type has an advantages that each cell acts as a self-supporting independent unit. Hence, each cell can be filled completely to the top before starting construction to the next cell. The next one, diaphragm type. The straight diaphragm walls are connected to each other by sheet pipes arranged in the form of arches on either side. The radius of the connecting arcs is equal to the distance between the straight diaphragm walls. This type is advantageous as the effective width can be increased to desirable limits without increasing the interlock stresses. The next type is rock-fill cofferdam. The stones are assembled in the required shape of the cofferdam and the piles are filled partially with the soil or earth and with stone chips in this type of cofferdam. Then we are going to discuss about the advantages of cofferdam. Cofferdam allow excavation and construction of structure in otherwise poor environment. Then it provides safe environment to work. Then contractors typically have design responsibility. Then steel sheet piles are easily installed and removed. Materials can typically be reused on other projects. This type has an advantage that each cell acts as a self-supporting independent unit, and in case of one of the cell collapses due to scur or interlock damage, it does not produce any adverse effect on the cell. This is related with diaphragm type cofferdam. See the image of diaphragm or circular type cellular cofferdam. This one is a rock-fill dam. If stone is abundantly available near the site, rock-fill cofferdam can be preferred up to the height of 3 feet. The next one is fibro-flotation. The fibro-flotation is a ground improvement technique used at a considerable depth that, by using a powered electrically or hydraulically through, it strengthens the soil. The hydro-flotation will compact the soil, making it suitable to support this high load. The fibro-flotation is a method of densifying loose sand or soil containing, thereby improving load carrying capacity of soil. Fibrofloat is a penetrator about 40 cm in diameter and 1.5 meter long. Inside the cylinder, an eccentric load is placed and it is rotated at very high speed. Jets are provided at top and bottom to allow 300 liters of water per minute, producing pressure of 4 to 5.5 kg per centimeter square. Generally, the fibroflotation this method is described into different steps. This method is developed in India and it helps to increase bearing capacity and to reduce post-construction settlement in clay soil. This method can as well be used for densification of origin-less soil by use of fibrofloat. Hole to required depth is formed by inserting petrol float in thick soil and it is up to 6 to 40 mm. Then pre-bearing capacity of stone column increases number because of end bearing, but due to local perimeter shear, stone columns give adequate bearing capacity, but settlement remains of much concern. Stone columns are useful in soft inorganic cohesive soil, but not in highly organic silts, clays and thick deposit of feed. Then in preloading method, the preloading generally refers to the process of compressing the soil under applied vertical stress prior to construction and place of the final construction. The two common preloading techniques are conventional preloading, that is by means of an embankment and vacuum-induced preloading. The purpose of preloading and vertical drains is to increase the shear strength of the soil, to reduce the soil compressibility, and to reduce the permeability of the soil. This is the method of preloading. First one is surcharge, then it comes under preload, and then slow draining subsoil. The next point we are going to discuss about is some factors influencing the swelling of soil. The first factor influencing the swelling of soil, type and amount of clay. Then second one is water content of sample. Then initial dry density. Then surcharge. Then method of compaction. Then time. Then difference between laboratory and field testing. These are the some factors. In type and amount of clay, for a given type of soil, swelling potential depends upon clay content and type of clay. Swelling potential increases with increase in clay content. Increase in clay content of the three clay minerals, that is, kaolinite, illite, and montmorillonite. Out of this, montmorillonite exhibit very high swelling characteristics. The next factor, water content of sample. Soil sample with lower water content will swell more, whereas soil having high initial water content will swell less. The next one, initial dry density. The sample with high initial dry density indicates that there are more soil grains, and if these grains are of swelling nature, then sample will swell more. The next factor, surcharge. For same initial dry density and water content, if surcharge on soil is increased, the amount of swelling and swelling pressure is less. Then method of compaction. Statically compacted soil swell more than those compacted by dynamic compaction or by cleaning. The next factor influence this swelling of soil is time. The samples under submergence swell even after 3 to 4 months and may continue for a long time. The difference between laboratory and field testing. Undisturbed samples swell more as compared to disturbed soil. Swelling pressure and percentage swell is higher in vertical direction than in lateral direction. The next factor we are going to consider, that is factors causing movement due to swelling. These are the some factors. First one, excavating and exposing of soil. In this factor, the excavating and exposing of soil around foundation leads to evaporation of moisture content. The next one, drainage. Due to excavation activities, existing drainage pattern may be changed. These affect water in deeper layer, thereby affecting deep-rooted expansive soil. The next one, changes in seasons or weather. During summer, water table may be very deep, and in rainy season, it may be very high. In expansive soil, effect of their changes may vary deep than in case of non-expansive soil. Then lowering of water table. Various construction activities like road cutting, tunnelling, construction of basement may require pumping of water, leading to lowering of water table. Similarly, water may be pumped for drinking, agriculture. Due to these all activities, the lowering of water table, thereby reduction in soil moisture. And due to this, the shrinkage of soil will be occurring. The next one, growth or removal of vegetation. Due to removal of vegetation, it also reduces the shrinkage of soil. Next one, watering in garden. Due to watering in garden, it soil swells due to high amount of water. The next factor we are going to discuss the methods of determination of swelling of soil. First method, the free swell method. Then second one, differential free swell method. Third one, constant falling method. The next one, consolidation method. Next one, surcharge method. These all methods is used to calculate the percentage of swelling of soil. In this all method, the soil pressure is most important. Swelling pressure is most important. The swelling pressure is defined as the internal pressure in soil when the soil is prevented from swelling. When it is allowed to take up water, that means swelling pressure. This is a differential free swell index test. It's used to calculate swelling, percentage of swelling. For this, we refer IS 2720 part Excel 1977. The following are the apparatus used to know the percentage of swelling by using free swell index test. We require ISU of size 425 micron. Then move on, then balance, then graduated glass cylinders having two numbers. These are different procedures. The next one, undering piles on black cotton soil. An undering pile is a pile of shallow depth 1 to 6 meter having one or more bulb at its lower end. In this type of foundation, the building or a house is anchored to the ground at the depth where the ground movement due to changes in moisture content is negligible. If the water table is high, bentonite slurry is used to retain the sides of the borehole against collapse. One can use one or more than one underlying piles with pile cap or column, depending upon the load of the column. See the structure of underlying piles. For construction of underlying pile, we require boring, then underlaying and concrete. In boring is usually done by manual earthwork and it is handled by a tripod post and winch. It is vertically of hole is ensured by the leaf frame. The drill bits or chopping bits can be used for hard soils. And in underlaying, after reaching desired depth, borehole is expanded to form a ring or hull with underlaying tool consisting of two collapsible cross plates with a bucket at the bottom to collect scrap soil. The scrap soil collected in bucket is lifted up and disposed of from time to time. And in concreting, the concreting is required to be done after the boring. This is all about the foundation in black water soil. See the image of underlying pile. Here is the concreting tunnel. Here is the concreting tunnel. Then this one bore ready for concreting. This one is reinforcement. This is the construction underlying pile. Thank you.